Swift 5 is changing the way string interpolation works. So in this video, I want to walk you through what's changing and why. Now you're probably thinking string interpolation is very boring. It's old news, who cares that it's changing? Please stick with me though. I hope you see it's changing in a great way so you can do some really cool things with it. Now you should know that string interpolation has been in Swift since the very earliest days. We can say let age equals 38, print you are age, to use string interpolation to say you are 38. But that was a huge quality of life improvement at the time, because before that we were writing code like this. NS string with format, @%ld, parens long, unread count. Much longer piece of code with the same sorts of functionality. But as well as being a quality of life improvement, it was also a major performance improvement, because it stopped us writing code like this. Let all equals string 1 plus string 2 plus string 3 plus string 4. This is very slow code. So what will happen is Swift will add string 1 and string 2 together first to make string 5. It'll then add string 5 and string 3 to make string 6. Then add string 6 to string 4 to make string 7. Then assign that to all. So there's much more work happening here. Apart from that, not much has changed. In Swift 2.1, we had the ability to have string literals inside our interpolation. So we could say print user, or with nil coalescing, anonymous as a literal string. But Swift evolution, of course, keeps driving our language forward quickly. Draft proposals come in, they get discussed, modified, and hopefully accepted, or maybe rejected. They keep driving the language forward. 2 or 3 times a year now, we get new Swift versions. Just Swift 4.2, a minor release, added things like case iterable, i.e. derived enum collections, hash warning and hash error, random number generation, improved hashable, and more, and that's in a minor release. Of course, Swift 5 is coming very soon, and the biggest feature there is ABI stability. But once again, there are many other things coming inside there. Things like raw strings, and compact map values, and of course the amazing new result type. So it might feel very much like Swift evolution is out to get your project. No matter how fast you update it, there are always more changes coming. Well, at long last, having survived from Swift 1 through to Swift 5, Swift evolution is coming for our string interpolation. It's being replaced with something much faster and much more powerful. To see how this works, let's go over to Xcode. We're going to start with something really simple. If I make a new age integer like this, let age equals 38, it feels pretty obvious that I can use that with string interpolation. I could say print, hi, I'm age. And this string interpolation here, of course, will just work, and it'll print, hi, I'm 38. But what if we decided we want to format that age differently? Well, here's where we get the new Swift 5 string interpolation system. We can write a new extension on string.string interpolation, where string interpolation is controlled. And inside there, I make a new method called append interpolation, which takes a value which is some sort of integer. And inside there, I'm going to say we'll have a number formatter, where the number style of that, how it writes numbers, is going to be .spellout, my personal favorite. And then, if we can read a result from that formatter, using from value as ns number, little typecast there because reasons, thanks Swift, we will append literal result. Now it'll now print out, hi, I'm 38. So what's happening here is this append interpolation method is overloaded. It can take any different kind of parameters, and here we're using a value integer. Inside there, where we try and interpolate an integer, we are first creating a new number formatter, saying to spell out the numbers as letters, trying to convert our integer to a number as letters using the formatter, and appending that to our string instead of the regular integer. And we can use the same technique to change date formatting, because by default they don't look great. I'll show you down here, if I do print today's date is string interpolation, a new date, you'll see the format is year, month, day, hour, minute, second, then time zone. It's not a great format. We can fix that with a custom date interpolation. We'll say mutating func, append interpolation. I'm going to put that on my clipboard actually, it's much easier. There we go. Where the value this time is some sort of date. I'll say let formatter equals a date formatter. formatter.dateStyle is equal to .full, longest dates we can do. Then make a date string from formatter.string from our value date and append that to our output. Append a literal date string. And now we'll see today's date is Wednesday, February 20th, 2019. That looks much better. And this kind of customization possibility is at the heart of this new string interpolation system. We have much more control over how it works. Now I should say, to avoid confusing your colleagues, you probably shouldn't override Swift's defaults. So here we're appending an integer, changing the default behavior of Swift. A better idea is to use a named parameter here, like format value. So now it's clear we're triggering custom behavior. So I'd have to call this thing by saying, hi, I'm format age. And that will call our custom interpolation. But it also shows how we have complete control over the way string interpolation handles parameters. As you've seen, append interpolation is overloaded. We have one here and the same method here. And it's overloaded based on the type of thing being passed into it. Here's integer and here it is a date. Let's add one more. I'm going to say, I'll paste it in my pasteboard, append interpolation was some sort of Twitter string. And this time I will append a literal being a HTML link to my Twitter account, whichever one's linked in interpolation. I'll say, hey href equals / quote, https://twitter.com/string interpolation, my Twitter account, which is passed in by the parameter. Then end the quote. Then add it again. We'll do actually at / even nicer. And then end the A. We can call that down here by using something like print. You should follow me on Twitter. I am Twitter, quote, 2 straws. And our custom interpolation, this thing here, is causing Swift to print out the full HTML link for following me on Twitter. Rather than having to have that inside the string, it's now done externally. And we don't need to stop at one parameter. Up here, for our number example, we have this format value thing. But why do we force people to use the number style spell out? We can change the method to add a second parameter. We could say format value int, then using style, a number formatter dot style. And use that inside the method by saying not just spell out, but our style. And now when we call that, we've got to say print hi I'm format age, comma, using dot spell out. And that will trigger our new interpolation. You can have as many of these parameters as you want, and they can be whatever you want too. An example I like to give folks is using auto closures with a default value, like this. I'll say mutating func append interpolation, this time using a values array, which is an array of strings. But if that array is empty, I want to print out a default value, which is going to be at auto closure, takes no params, returns a string. Then inside there we'll say if values.count is 0, if the array is empty, we will append literal and call default value. Else, if the array has some values, we will call append literal values.joined using the separator, comma, space. And with that in place, we can now call this method. Down here, we'll say let names equals. If you're a Firefly fan, we have Malcolm, we have Jane, and we have Kaylee. And we can now print those out using our string interpolation by saying print crew is names, empty will be no one. Now using this auto closure attribute here is really important because it means we can pass in complex functions if we want to for our default value. Because the function's only actually executed if values is equal to 0. Otherwise the function isn't touched. So it's passing in some code to say, run this if you need to get the default value, otherwise don't run it. So it has no cost when the array is not empty. Now we could, of course, rewrite this code without using Swift 5's interpolation system. We could have said instead, an extension on arrays that happen to contain elements that are strings. And we'll make a new thing in here called formatted. This will take an empty default value again, which is again auto closure, takes no parameter, returns string. But now the whole thing must return a string. And we'll say if count is equal to 0, return default value, calling it again at auto closure, else return self.joined separator, comma, space. And we use that in very much the same way. We'll say instead, print the crew will be names.formatted, empty, no one. And the output's the same. But now we're just kind of cluttering our call site here. We're obviously trying to format something, because that's the point of string interpolation. If you remember the Swift style guide, omit unnecessary words. We are. And we're literally taking the word formatting out of this call when we're using the interpolation approach, because we're always formatting stuff here. That is, of course, the point of interpolation. Now, Eric Sedun gave a really short and sweet example of how this can help clean up your code. I'll show it to you here. I'll paste it in again, my mutating func append interpolation. Her example is this. If condition, and this time the condition is the auto closure, takes no param, returns a bool, then the second value will be a string literal type, some sort of string. Inside there we'll say guard condition, else return, so get out immediately if our condition failed. And finally, append literal, the literal. So if it succeeds, append the actual string. So now down here, we can say let does Swift rock equal true, print Swift rocks, and then string interpolation, if does Swift rock, then print a star in parentheses, end the string, end the parentheses, end the string, end the parentheses, and that will print out Swift rocks, then a star next to it. But if Swift rocks was false, this thing here is false, it does print out Swift rocks, then nothing at all. Again, we could do that without the traditional string interpolation. We could have used, say, a ternary operator instead. We can print Swift rocks, colon, and the interpolation would use something like does Swift rock, question mark, print the star, colon, print an empty string, then end the whole thing. You can add interpolations for your own custom types too. If I have a struct person, I'll say var type is a property of string and var action property string. I'll then add a new extension on string.string interpolation. This time my person value will be a type of person. I'll call straight away append literal I'm a person dot type and I'm gonna person dot action. We can now write let hater equals a person, the type is hater, and the action is hate. We can do print status check hater. As Taylor herself taught us, hater's going to hate. Now the nice thing about using string interpolation here is that we don't touch the object's debug description. If we view this thing, our hater instance, in a debugger, or we try to print it out directly, we get the original untouched data that we got previously. So if I just do in here, print hater, you'll see back the regular Swift debug description for that thing. Person type hater, action hate. We can even combine that custom type with the multiple parameters from earlier. Let's add a new interpolation here. I'll say mutating func append interpolation again with the same person value, but this time a count integer. And I'll say let action equals a string repeating the action of that person with a space count times. Then say append literal a new line, string interpolation, person.type.capitalized, with an S on the end, gonna, string interpolation, action. And now if we scroll down, we already have hater here. We'll add a few more to here. We'll say let player equals a person with the type being player, action, play. Then we'll do heartbreaker equals a person with the type heartbreaker, action will be break. And finally, let faker equals a person with the type faker, action, fake. And now finally, we can say print, let's sing player, count 5, then hater, count 5, then heartbreaker, count 5, then faker, count 5. And as you can see, that is the lyrics to Taylor Swift Shake It Off using string interpolation. You can, of course, use the full range of Swift language features to craft your custom interpolations. For example, we could write a simple debug interpolation that accepts any kind of encodable object and prints it as JSON. If I go up here again, mutating func append interpolation, this time generic over T, where T must be some kind of encodable thing. This will take some sort of debug value of type T. We can say let encoder equals a new JSON encoder using the output formatting of .prettyprinted. And now we can say if let result equals try question mark encoder.encode the value. If that succeeds, we'll get back to a string again by saying let str equals string decoding the result as utf8.self and append literal, that's string. So this will let us encode any kind of thing using the JSON encoder and with pretty printing. Just one line of code now we can start doing things with this. We could say, for example, that our person struct up here, this conforms to encodable, and use that by saying down here, print, here's some data, debug, faker. As you can see, it's now printing out the output JSON for that object. You can also use things like variadic parameters and even mark your interpolations as throwing. For example, we have up here this generic append interpolation that'll handle encodable things, but it actually consumes any errors that are thrown inside the method, which isn't really ideal. A better idea is to make this interpolation throw. So I'll mark this method here with throws, and then say, let's get rid of this entirely. There's no more optional try. This assume will always work, and let the call site handle the error. So now Swift's warning us that down here we're using debug interpolation. This thing can throw, but it's not marked with try. As a result, creating this whole string literally can throw. So you want to say print try that string. You've got to use try and catch here. Now everything we've looked at so far is just modifying the way strings do interpolation. As you've seen, this is really about controlling the way data is formatted in our apps in a really clean way. We can also use this to build our own types using interpolation. To demonstrate this, we're going to design a new type that can be instantiated from a string using interpolation. In this example, we're going to design a type that lets us make strings in various colors using attributed strings. We'll say there's a new struct called a colored string, which must conform to expressible by string interpolation. Inside there, just like with a string type, we have to have our own string interpolation nested struct. So we'll say struct string interpolation conforms to the string interpolation protocol. Now this thing needs to have a scratch pad where it can build up its attributed string from various string interpolations. So we'll say var output equals an NS mutable attributed string. As you know, attributed strings have to have some attributes behind them. So we're going to define some default attributes for the way our text looks if it has no styling. So I'll say var base attributes is a dictionary of NS attributed string dot key colon any with the value of a font of UI font. I'll use Georgia italic, a bit fancy, with the size of 64. If that fails though, I'll use a .system font of size 64. And for a foreground color, I'm going to use UI color .black. Next, we have to add an initializer. Now there's one particular initializer we need, which will tell us how many characters of literal string were given and how many interpolations. And you can use this very often to have allocations for space. You can reserve capacity ahead of time as performance optimization. In our case though, we're using an attributed string, so it'll do its own memory allocation automatically. So we'll do init literal capacity, int interpolation count, int open and close braces. So this will tell you again how many interpolations to expect and how much of a literal string to expect as well. Next up, we need to implement a method that will append a literal string when someone types exact text hard-coded into Swift code. So I'll do mutating func, append a literal, which will be some literal value of a string. I'm going to make it print out what it was adding, so you can see more clearly how this thing works. I'll do appending literal with a string interpolation. And then I'll wrap that in our base attributes. So we have a basic sort of attributed string we can put into our main scratchpad. So I'll say let attributed string equals an NS attributed string, with the string being our literal and our attributes being our base attributes, the ones we defined earlier, the nice big Georgia italic. And then we'll append that to our scratchpad. So that's if we're given an exact hard-coded piece of text to show. If we're given interpolation, what do you want to do? Well, I already said this thing's going to have some sort of coloured strings attached to it, so our interpolation will handle a message string and a UI colour. So I'll say, mutating func append interpolation, our message string, and a colour that's a UI colour. Again, I'll print out the string so we can see how it's working. Appending message. But this time we want our color applied to our base attributes. So I'll say var colored attributes is our base attributes, but it's now variable, so we can modify it. We can say colored attributes dot foreground color equals the color that was passed in. We can then wrap that in a new attributed string again by saying let attributed string equals an NS attributed string with the message and the attributes being colored attributes. And append that to our output. Output.append attributed string. So that finishes off our internal type. This nested type here, string interpolation. That completes that type. Remember, this thing is a scratchpad, which means it's used to hold temporary values as we're assembling a string from interpolations and literals. When it's finished, when that thing is totally finished, it will create an instance of our outer type, this colored string, passing in the finished interpolation ready to be used with real stuff. So, in this struct, like outside this inner struct, below this thing here, just here, so in our main struct, we're going to say this thing has a value which is a regular attributed string. Not mutable anymore. It's a regular attributed string because the mutable one was only needed in the scratchpad. This thing's now finished, it's parsed the whole string, we can forget about mutability now. It does need two initializers though, so let's add them now. One is init string literal, a value string. So if someone tries to create this thing with a simple raw string, no attributes whatsoever, I'll just say self.value equals a new NS attributed string with that value. No formatting whatsoever. It's like a bare string. The other way this can be made is with string interpolation, and this will pass us an instance of our nested type, an instance of one of these things, which has its fully made attributed string ready to go, all with our message and colors or whatever, all formatted prettily and perfectly ready to go. So we'll say init with a string interpolation, and that's our nested type here, self.value equals that string interpolation dot output. That's the scratch pad we had earlier. And that finishes our type. So now we can go ahead and start using it. So we can say let stir is a kind of colored string with the value. String interpolation message was going to be red with the color dot red. Then the message white with the color dot white, and the message blue with the color blue. Of course, adding the color parameter in there. Now what you'll see is our appending messages appear nicely. Appending red, appending white, appending blue. And there are spaces in between for the string literals here, a little space there. There's one here as well. Can't really see it because the formatting has wrapped my text. But it appends those as string literals alongside the interpolations. And if everything's worked correctly, if I open up this preview, we should be able to see what the value looks like. Boom. Red in red, white in white, and blue in blue. It's the British flag, or the French flag, or the American flag, or any number of flags in red, white, and blue. Common colors. Now this is really just massive amounts of syntactic sugar. We could make this thing by hand if we really wanted to. We could have said something like this. Var interpolation is equal to a colored string dot string interpolation with literal capacity being 10 and interpolation being 1. I'll say interpolation dot append literal hello. Then interpolation dot append interpolation with the message string being hello in the color red. And then again interpolation dot append literal with the string hello. So that uses our scratch pad fully, so it's full of nice text. And then wrap that inside a new string by saying let new stir equals a colored string, passing in the string interpolation we just made, interpolation. And that will work correctly now. You'll see hello printed out 3 times down here. And we preview this, we should see our colored string nicely with black text, red text, and black text. Okay, let's wrap up. As you've seen, custom string interpolation lets us wrap up formatting code in one place, so we can keep our call sites clear. But it also delivers extraordinary flexibility for us to create types in a really natural way. Remember, this is only one tool in the toolbox. It's not your only tool. Sometimes you'll use interpolation, other times functions, and other times something else. So, as with many things in programming, the key is to be pragmatic, to make choices on a case-by-case basis based on what works best there. At the same time, it's also extremely new, so I really look forward to seeing what folks build with it once Swift 5 ships as final. Speaking of Swift 5, there are lots of other amazing new features coming, like raw strings, like isMultipleOf, like the new result type. To find out more about this, go to my website just for this information. It's called whatsnewinswift.com. Easy to remember, I hope. You'll find lots of examples there, lots of videos, lots of interactive playgrounds where you can see exactly what's changing and why. If you want to learn more about string interpolation, here are some resources to check out. The first one is bit.ly/interpolate1. That is the Swift evolution proposal describing why it's changing and what you can do with it. There's a great post from Erica Sadun at interpolate2 where she goes into examples of handling radixes for numbers, for example, or date formatting. Go and read her article there. Interpolate 3 is an article from Olivier Hanagon where he goes through a more advanced attributed string, adding more formatting. Interpolate 4 is a great library from Ilya Puchka. It's more a proof of concept, where he builds a templating system for web frameworks entirely using string interpolation. And then the last one, Interpolate 5, is a gist on GitHub from Brent Royal Gordon, one of the writers of this Swift evolution proposal, but it goes into examples there of making HTML, SQL, and localizable strings. And now it's over to you. Leave a comment below saying what you learned in this video, and of course if you enjoyed this video, make sure you subscribe to my channel. I make lots more videos like this one.